Bridge over the Danube in Bulgaria. In this video, VIDIN Construction presents its proposal for the design and construction of the bridge over the Danube River between Vidin and Calafat. VIDIN has developed a design with the engineering consultant company Carlos Fernandez Casado that complies with all the prescriptions of the tender dossier, drawing up a high-quality tender based on its experience and know-how. The design presented by VIDIN Construction provides an integrated solution to the crossing of the Danube for road and rail traffic. The central area within the bridge section cross houses the railway track using both sides for car traffic. Once the crossing of the river has been dealt with, the bridge splits into two approach viaducts, one for the roadway with a steeper slope and the other for the railway that, tracing a wide bend, moves away from the horizontal alignment of the hull. According to this solution, the bridge is composed of three clearly different structures. The main bridge for the river crossing is a stayed structure made up of 5 spans. The central spans allow for the Danube River navigation channels. To improve the structural behavior of the central spans, sloping struts have been provided starting from each pier and fixed to the deck. These elements allow for reduced constant depth of the deck, improving the structural behavior of the stay system. The stay system on the bridge is double, so that each tower splits into 2 masts, joined together by a transverse strut that also provides support for the deck at piers. Each tower supports 9 cables that cross the tower through a saddle bearing that allows the change in direction of the stays that are anchored only to the deck at both ends. The cross-section of the deck is formed by a single box girder with a depth of 4 meters and a width of 7.20 meters and 2 side cantilevers of 11.20 and 12.95 meters respectively, shored by sloping reinforced concrete struts. The towers have deep foundations made of driven steel piles. In order to provide protection against ship impacts, 30-meter diameter sheet pile cofferdams are provided around the towers. These cofferdams will be backfilled with granular material and their crown level will be above the highest water level. The road approach spans is a continuous pre-stressed concrete girder of 612 meters long, made up of 7 80-meter spans and an end 52-meter span. The cross-section is the same as that of the main bridge, although the overhang of the side cantilevers is 1 meter less. The foundation of the piers also consists of steel piles fixed together by a reinforced concrete pile cap. The railway approach spans consists of a continuous pre-stressed concrete girder with constant depth and a length of 952 meters, composed of 23 equal spans of 40 meters and 1 end span of 32 meters. The cross-section of the deck is made up of 2 rectangular beams with a depth of 1.89 meters and a width of 1 meter, set 6.70 meters apart. The beams are joined together by a reinforced concrete slab 25 centimeters thick and 8.60 meters wide. The horizontal alignment of the viaduct follows the road approach to the starting point of the 1500 meters radius bend. So as not to interfere with the road platform, the bridge is supported on piers along the 4 spans involved. The bridge is supported on pairs of circular piers supported on the roadway approach deck in the section where they match in direction. All other piers are founded by means of single reinforced concrete piles with a 2-meter diameter steel casing, except the frame piers that are founded on 2 identical piles fixed together by a reinforced concrete pile cap.